Coal is a fossil fuel extracted from the ground by underground mining or open pit mining, that is surface mining. It is a readily combustible black or brownish black sedimentary rock. It is composed primarily of carbon along with assorted other elements including sulfur. Often associated with the Industrial Revolution, coal remains an enormously important fuel and is the largest single source of electricity worldwide. Coal is the main source of energy not only in our country but also for most of the countries of the world. The energy requirement of India is increasing every year, and to meet this demand the country has to depend to a large extent on coal. At present, more than 60% of the total commercial energy requirement is met from the coal. India has the 5th largest coal reserves in the world. Of the total reserves, nearly 88% are non-coking coal reserves, while tertiary coal's reserves account for a meager 0.5% and balance is coking coal. Indian coal is characterized by high ash content of up to 45% and low sulfur content. The Indian coal deposits are primarily concentrated in the Gondwana sediments, upper Paleozoic to Mesozoic systems, occurring in the eastern and central parts of peninsular India. The coal is of bituminous to subbituminous rank and is restricted to the sediments of Permian age. The tertiary coal-bearing sediments are found in the northeastern India, spreading over the states of Assam, Arunachal Pradesh, Nagaland and Meghalaya, of which the Assam coalfields are the prominent ones. A total of 298.914 billion tons of geological resources of coal have so far been estimated in India, up to the maximum depth of 1200 meters. Out of the total resources, the Gondwana coal fields account for 2,97,421 million tons, that is 99.5%, while the tertiary coal fields of Himalayan region contribute 1,493 million tons, that is 0.5% of coal resources. As of April 2013, prime coking coal contributes about 79% to the coal reserves of the country, with medium and semi-coking coal contributing about 16 and 5% respectively. The inventory of geological resources of Indian coal is prepared by the Geological Survey of India (GSI). Coal reserves in India, as per Indian Standard Practice ISP guidelines, ISP does not distinguish between resources and reserves, are classified under 3 categories: pro-with, indicated and inferred geological reserves. In Andhra Pradesh, important coal fields lie in the Pranhita Godavari Valley. In continuation of the Varda Valley, there are coal fields in the Pranhita Godavari valleys, covering an enormous area of over 9,000 square kilometers. The lower Gondwana rocks, consisting of Talcher, Barkar and Kamti, are well developed in the area. The exposures of Barkar rocks are few. The coal fields are traversed by post-Kamti faults. The characteristic of the coal fields is that these are devoid of igneous intrusions. Based on geographical and geological considerations, the Godavari Valley coalfield is divided into 12 coal belts. Out of 57 Gondwana and 14 tertiary coalfields considered for the national inventory of the coal, Orissa state has only 2 intact, geologically only 1.5 coalfields. Yet, its share in the reserve so far established in the country amounts to 23.6%. The famous coal-bearing basins are Ib River coalfields and Talcher coalfields, and as a sequel to which, these coalfields have been added advantage of being accorded most favored coalfields status by nature as far as quarryable potentiality is concerned. A substantial quarryable reserve has been located in northern part of Ib River, Coalfield, Gopalpur area, and towards its southeastern extremity in Kinda, Talabira area. Occurrence of coal seams have also been reported from Raniganj formation of Ib River coalfield very recently. The importance of Orissa coalfields is further enhanced due to their proximity to the east coast. Coal sector in India. Coal deposits in India. Coal deposits in India are of two distinct geological ages. The earliest coal deposits are of Permian age, formed about 270 million years ago. At that time, South Africa, South America, Antarctica, Australia, India and Madagascar formed a landmass called Gondwana land. Coal formed in Gondwana land is known as Gondwana coal. Other deposits of tertiary age, Eocene, 30 to 60 million years have been formed comparatively recently. These are known as tertiary coal. India has the fifth largest coal reserves in the world. Of the total reserves, nearly 88% are non-coking coal reserves, while tertiary coals reserves account for a meager 0.5% and balance is coking coal. Indian coal is characterized by high ash content of up to 45% and low sulfur content. The commercial coal in the country is mainly consumed by the power, steel and cement sector. The Indian coal deposits are primarily concentrated in the Gondwana sediments, upper Paleozoic to Mesozoic systems, occurring in the eastern and central parts of peninsular India. The coal is of bituminous to sub-bituminous rank and is restricted to the sediments of Permian age. The tertiary coal-bearing sediments are found in the northeastern India, spreading over the states of Assam, Arunachal Pradesh, Nagaland and Meghalaya, of which the Assam coalfields are the prominent ones. Indian lignite deposits occur in the tertiary sediments in the southern and western parts of the peninsular shield, particularly in Tamil Nadu, Pondicherry, Gujarat, Rajasthan and Jammu and Kashmir. A total of 298.914 billion tons of geological resources of coal have so far been estimated in India, up to the maximum depth of 1200 meters. Out of the total resources, the Gondwana coal fields account for 2,97,421 million tons, that is 99.5%, while the tertiary coal fields of Himalayan region contribute 1,493 million tons, that is 0.5% of coal resources. As of April 2013, prime coking coal contributes about 79% to the coal reserves of the country, with medium and semi-coking coal contributing about 16 and 5% respectively. The inventory of geological resources of Indian coal is prepared by the Geological Survey of India (GSI). Classification of coal in India. Depending upon its grade from highest to lowest following, the coal found in India can be classified as anthracite coal, bituminous coal, lignite or brown coal, peat, etc. Anthracite coal. This is the best quality of coal and contains over 85% carbon. It is very hard, compact, jet black coal having semi-metallic luster. It ignites slowly and burns with a nice short blue flame. In India, it is found only in Jammu and Kashmir, and that too in small quantity. Bituminous coal. This is the most widely used coal and contains 50 to 85% carbon. It is dense, compact and brittle and is usually of black color. A good bituminous coal is composed of alternate dull and bright bands. Its calorific value is very high due to high proportion of carbon and low moisture content. Most of the bituminous coal is found in Jharkhand, Orissa, West Bengal, Chhattisgarh and Madhya Pradesh. Lignite or brown coal. Also known as brown coal, lignite is a lower grade coal and contains about 35 to 50% carbon. It represents the intermediate stage in the alternation of woody matter into coal. Its color varies from dark to black brown. It is found in Palna of Rajasthan, Neyveli to Tamil Nadu, Lakhimpur of Assam and Kareva of Jammu and Kashmir. Peat. This is the first stage of transformation of wood into coal and contains less than 35% carbon. It is seldom sufficiently compact to make a good fuel without compressing into bricks. Left to itself, it burns like wood, gives less heat, emits more smoke and leaves a lot of ash after burning. Coal reserves in India. Coal reserves in India as per Indian Standard Practice ISP guidelines. ISP does not distinguish between resources and reserves, are classified under three categories: Pro-with, indicated and inferred geological reserves. Pro-with geological reserves represent resource base with the highest confidence. The delineated tonnage within an area falling within a radius of 200 meter around boreholes is categorized as Pro-with geological reserves. Pro-with geological reserves can be produced only on the completion of detailed exploration. Indicated geological reserves comprise that material occurring within a radius of 1000 meter around boreholes taken up for regional and detailed exploration. While estimating indicated geological reserves, qualitative information obtained from the regional exploratory boreholes are projected in the indicated geological reserve category. Inferred geological reserves comprise that material occurring within the influence area beyond 1000 meter and up to 2000 meter from the point of observation. Geological and geographical distribution of coal fields of India. In India, 99% of our coal production comes from the Gondwana coals, which are found in three geological units: Raniganj Formation, Upper Permian; Barkar Formation, Lower Permian; and Karharbari Formation, Lower Permian. Karharbari Formation is the oldest formation in India where coal has been found. The Gondwana coals of Permian times are mainly found in the peninsular Gondwana basins of India. Coalfields of West Bengal. In West Bengal, Raniganj coalfield is the important coalfield. This coalfield is the easternmost of the Damodar Valley coalfields. The coalfields lie mostly in the West Bengal and partly western portion of Bihar. Next to Jharia coalfields, this is the most important coalfield in India. It is situated about 185 km northwest of Calcutta. The field is named after the town Raniganj, which is situated in the southeastern part of this field. The coal field is surrounded by the Archean rocks on all sides except in the east. Coal-bearing Gondwana strata lie beneath the alluvium cover. Coals of the Barkar measures are low in moisture, 1 to 3%, low in volatile matter, 20 to 30%, whereas coals of Raniganj measures are high in moisture, 3 to 10%, and high in volatile matter, 30 to 36%. Other coalfields found in West Bengal are Barjora coalfield, Birbhum coalfield, and Darjeeling coalfield. Coalfields of Jharkhand and Bihar. About 1/3 of the estimated coal reserves are distributed in the coalfields of Jharkhand and Bihar. Important coalfields of this state are Jharia, Bokaro, Giridih, Karanpura, Ramgarh, Daltonganj, Auranga, and Hutar. Part of the Raniganj coalfield of West Bengal falls in this state. Coalfields of the Damodar Valley are the chief source of metallurgical coal in the country, and most of the iron and steel plants get coking coal from these fields. Relative significance has declined drastically from 47% of total coal production in the country in 1970 to 26% in 1998-99. Consequently, it has come to second place among the coal producing states. Damodar Valley coalfields. Jharia coalfield. Jharia coalfield is the most important coalfield in India. This is because this coalfield is now the prime depository of prime coking coal. This coalfield is situated about 260 km northwest of Calcutta in the heart of Damodar Valley, mainly along the north of this river. The coalfield lies within the district of Dhanbad. The field is roughly sickle shaped. The coal basin extends for about 38 km in an east-west direction and maximum of 18 km in north-south direction, and covers an area of about 456 square kilometers. The general stratigraphic succession of the area is that the basement metamorphic rocks are overlain by the Talchir formation, followed by the Barkar formation, which is the main coal-bearing horizon. Above it comes the barren measures, which is followed by the coal-bearing Raniganj formation. The Raniganj formation is the uppermost coal-bearing formation in the Jharia coalfield. The coals of the Barkar formation may be divided into low volatile coals containing up to 26% volatiles, medium volatile coals containing 26 to 28% volatiles, high volatile coals containing over 28% volatiles. The coals of the Raniganj formation have slightly higher moisture content than the coals of Barkar formation. Bokaro coalfield. This coalfield is in the form of a long narrow strip extending for about 64 kilometers in an east-west direction with a maximum width of about 11 kilometers in the north-south direction. The Barkar formation is the chief coal-bearing horizon. This field is divided into two parts by Lugu Hills, East Bokaro coalfield. There are several coal seams within the Barkar formation. Lower coal seams are grouped as Karo group, in which there are 11 coal seams. Out of these seams, Karo lower measures 19 to 64 meter and Karo upper measures 18 to 16 meter are worth mentioning. The moisture content of this coal is low and the coals are medium quality coking coals. West Bokaro coalfield. The Barkar formation is coal bearing and embodies 13 seams. The quality of the coal varies widely in this field. In most of the seams, the ash content is high, greater than 25%. Most of the coals are medium coking coals. Karanpura coalfield. Just to the west of Bokaro coalfield lies the Karanpura coalfield. This coalfield is divided into two parts, North Karanpura and South Karanpura. In Karanpura coalfield, there is full development of lower Gondwana and the younger rocks. In the North Karanpura, a number of coal seams occur. The ash content of these coal seams is high. In South Karanpura, there is good development of Talcher and Barkar formation. Most of the coals of this area are non-coking. North Koil Valley coalfields. There are three coalfields, Auranga, Hutar and Daltonganj in the valley of Koil river, a tributary to Son river. The Auranga and Hutar coalfields are in the same alignment with those of Damodar valley, while Daltonganj coalfield is somewhat north of axial line. Hutar and Daltonganj coalfields are of economic importance. In Hutar coalfield, coal seams occur in lower Barkar. A number of coal seams have been reported. The coals are low in volatile matter, 12.6% and ash content 17.67%. Diogad coalfields. The Diogad group of coalfields comprises three isolated lower Gondwana sedimentary basins such as Jayanti, Sarjuri and Kundit Kurhaiha. These basins forms a northwest-southeast trending belt and are located in the Santal Pargana districts of Bihar. The coal seams are reported to occur in the Karharbari as well as Barkar formation. The coals are high in ash and range in rank from subbituminous B to high volatile bituminous B. Rajmahal coalfields. The coalfields of this area are assuming importance lately. The unique location of the coalfields at the southern bank of the Ganges offers a good possibility of supplying coals to major power stations of North Bihar, North Bengal and Bangladesh. Based on the coal of this region, a super thermal power station has been built at Farakka. There are 5 coalfields in this area. Coals of this region are subbituminous to high volatile bituminous in rank. Hazaribagh coalfields. Girdi or Karharbari coalfield is the most important coalfield amongst the Hazaribagh group of coalfields. Some of the best coking coals were extracted from this coalfield. Besides, Girdi coalfield is the type area of Karharbari formation. The coal from the seams are low in moisture 1.4 to 1.8%, low in ash 9 to 12.6%, low in volatile, low in sulfur 0.5% and phosphorus 0.01%.